Welcome to the Master The NEC Podcast, the ultimate destination for anyone passionate about the electrical trade. Whether you're a seasoned electrician, an eager apprentice, or just someone who wants to dive deep into the world of electrical work, you've come to the right place. Join your host, Paul Abernathy, a true authority in the industry with over 38 years of trade experience, as he electrifies your mind with in-depth discussions, expert tips, and valuable insights that will keep you ahead of the curve. Each episode, Paul will illuminate the complexities of the trade, decode the National Electrical Code, and share the latest industry trends, all while empowering you to take your electrical career to the next level. So, gear up, plug in, and get ready to supercharge your knowledge, because with the Master The NEC Podcast, the power is in your hands. Now get ready. Here is your host, Paul Abernathy.
What up, everybody? Welcome to another episode of Master The NEC Podcast. My name is Paul Abernathy, and I am your host of the show that helps electricians, contractors, inspectors, and electrical professionals stay sharp, stay focused, stay informed, keeps you ahead of the curve when all things electrically related. And so thank you for taking the time out of your day to join me here on the podcast. Hopefully you're going to get something out of today's podcast. And today's episode is sponsored by thermalelectrician.com, which is our certification program for all electricians who want to become very proficient with thermography that's specific to electrical applications. Okay, home inspectors, other inspectors do things, building envelope stuff, but this program focuses very specifically on thermal imaging as it is for electrical applications. And again, understanding the different nuances for terminations and ratings and all that kind of stuff. And so that is who sponsored today's podcast. And so if you're thinking about becoming a thermal inspector for electrical, if you're thinking about adding thermal imaging to your electrical contracting business, all those type of things, then our program can literally help you. And you might as well get certified while you're at it. So that's what our program does. So check it out at thermalelectrician.com. We'd love to have you. All right. Well, in that same mode, today's episode is entitled, Why Every Electrical Contractor Needs a Thermal Imaging Camera and How It Will Transform Your Service Business. Because there are a lot of misconceptions out there when it comes to thermal imaging. I'll give you my brother, for example, been an electrician for damn near 50 years, has never used a thermal imaging camera in his practice. He's done a lot of troubleshooting. He's done a lot of things that maybe took a lot more time to find the problem than maybe it would have if he had a thermal imaging camera. And so, again, it's not a new concept. It's not, something that's, just now coming onto the industry. It's been around for a while. The only difference is that now we're thinking of it in a totally different light, in the sense that there is a lot of people that think they understand thermography, and they really don't. And they may cry wolf. They cause problems. They may be misleading people. And, at the end of the day, it's like with anything. When you're learning the National Electrical Code, you want to be as thorough as possible and have the best resources as possible. Well, we think that the course that we put together on the Thermal Electrician is the best out there. So if you're interested in getting a certification in that, this is going to be a good episode for you from an electrician standpoint, because we're going to talk about a lot of things that you may not even think about. And so we're going to kind of dig into that. So it's really not a situation. It's really about why every electrical contractor out there, you have tools, you have meters, you have clamp on amp probes, you have all kinds of stuff, but every electrician out there should have a thermal imaging camera in their toolbox. And today they are so freaking affordable. And with our new partnership with Mousy, you can get the best professional grade thermal imaging camera at the best possible prices through us. And we're excited about that partnership. And we're going to be their exclusive educator, and we're going to exclusively promote their thermal imaging cameras. And so you're going to see a lot of collaboration between us and them because we believe that that's what it takes. It needs expert training to fully understand how a thermal imaging camera works. So every electrical contractor should at least have a thermal imaging camera in their toolbox. And they're not all created equal. Okay. So again, we're more than happy to help talk you through. There's different price points, different levels of what you may need, and we can help you with that most certainly. Just check us out at thermalelectrician.com. Or, of course, you can go to the parent company, electricalcodeacademy.com or fasttracksystem.com and reach out to us that way. Even use the Let's Ask Paul if you want to ask more detailed questions. Feel free. We're more than happy to help you. So today for electricians and what they learn, part of all learning should be, even in vocational school, now they should be curriculum now on thermal imaging. And we have a program that we can put right into a vocational school. Just reach out to us. We can even show you with demonstration and everything like that what you need. And it's amazing if you use it properly, what you can actually do with it. So it's not really an add-on anymore. It is something that we do that's not you do sometimes. It should become a standard part of your professional toolkit. It's just like any other tool. And the reason for that is times have changed. We always, as electricians, we end up going to projects after stuff has failed. When we may be there for one reason, and we can head off of another problem by simply offering the customer an evaluation, and we're already there. So we're not just talking about property maintenance. We're not just talking about preventive maintenance. We're not just talking about data centers, commercial, industrial. We're talking everyday residential all the way up to large-scale commercial. You need at least somebody in your company that understands thermal imaging. Again, it's not just as simple as looking at a color palette and saying, oh, that's hot, that's going bad. That is not true. Okay, so again, a lot of misleading information on there. Now, what we're going to do here in this podcast today, hopefully you listen to it, is that we're going to introduce a little bit of 70B requirements because that's becoming something that's very important now, not just NFPA 70, but 70B starting to rear its head, okay, especially for maintenance and existing systems. We're going to talk about how to create proper loading because there are aspects of 70B that talk about a 40% loading threshold and how you may do that on a simple service call. And it's easier than you think, okay? We're going to talk a little bit about residential and commercial applications, how you would apply this. We're also going to be talking about something that people don't think about, and that is the I2R heating and the hidden failures that are just waiting to be a problem. Now, this is not just in residential. This is commercial. This is why you do preventative maintenance, because sometimes looking at something, you can't really see the full story of what's going on. And I'm going to tell you right now, when you get into a program like ours and you learn things like emissivity, and you realize that the front of the breaker that's plastic is not exactly telling the story about what's going on behind the breaker. And because of the material that you're measuring on, whether it's something that's giving a reflection, that's giving false readings, or the emissivity value is very low versus very high, which means it's going to give you a more accurate reading the higher it is. If you don't understand these things, if you don't understand all of those nuances, then you could be crying wolf. But you also can be very preventive. And if you're on a service call, there are things that you can do that will actually help your customer. And you're not selling snake oil. You're actually selling them something that can save them a lot of money down the road if you can find the problem now. And that can be. So we'll talk a little bit about thermal diagnostics and how that increases your profitability as a shop owner, as an electrician. And it also gives you a skill set that you can use in your job interviews and how you go from company to company, or if you grow your own. And also why it's essentially mastering the skills is essential today for modern electricians. It's essential that you understand not just how to look at a color palette on a thermal imaging camera, but understand truly what is going on in that color palette. How to change, again, things like emissivity, how to do a quantitative versus a qualitative review, how to do peer review, look at two different points on a thermal imaging camera and come to a peer review understanding of what's going on. how the load is transitioning through things like contactors versus fuses versus disconnects. This is some intricate stuff, and it's not just getting a camera, but truly understanding how it works. And really, every electrician has a pair of clines. Every electrician has drills. Every electrician needs to have a thermal imaging camera, and they need to understand how to use it. Now, here's the big difference between us. Okay, I'm going to be real with you. You're not going to spend $2,000, $3,000 taking a full-fledged thermography course because you don't need it. As an electrician, you want your training to be focused. We are offering the world's only specific thermography course dedicated just to electricians. Now, there are other courses that offer thermography for the electrical aspects of it, but they don't get into the details like we do. We talk about conductors and ampacity and how it works and the history behind it and all things to be aware of and what to look for. They don't tell you how to sell it to the customer, how to explain it in clear understanding. We do all that in our program. So right now, you can get thermography certified, level 1, level 2, level 3. But I'm only focusing on electricians, and so we sat down and created a program just for electricians. Now, you might say, well, what's the certification backed by? Well, I'll be honest with you. There is no accrediting body for certification when it comes to thermal imaging and thermography, especially in electrical. But the fact that you're a licensed electrician, your electrical professional already gives you a leg up because of licensure. And then we, as a corporation, throw onto that very specific training that is detailed specifically, and it's meeting all the equivalencies of other testing authorities in our program so that we meet or exceed the voluntary standards of the industry. But there's no licensing requirement, nowhere. So don't be fooled by that. What's the difference between our program is it's designed specifically to give you, the electrician. Now, if you're going to be a home inspector, or you're going to be a building envelope guy or gal, if you're going to go on to do those type of things, then by all means, there's a great programs out there that can get you to that level 2 and level 3 for that building envelope type of stuff. That is not what we're here for. I'm an electrician. I teach electricians. Electrical contractors need to understand how to troubleshoot things, how to use these thermal imaging cameras in their business, how electricians use them. I'm not interested in leaky water. I'm not interested in those type of things. We're only training electricians. There's a difference, folks. Our programs are designed for electricians. Google me. Google Paul Abernathy, the electrical guru, or Paul Abernathy, electrical expert, and you're going to see we have, whether you've never heard me before, I am backed by a foundation of educational knowledge that serves on code-making panels, written books, done training for decades. I would not put out a course unless it was dedicated to teach you what you needed to know. And here's the other thing about our program. We're going to continually keep adding to it more and more and more. So once you're in our program, you become a member for life. You do not expire out of a program. Now, we'll add updates, and to keep your certification current, you have to take those updates. But they're included in your current course. So again, it's fundamentally important for you to understand what we're trying to aim at teaching you here. Thermography for electricians and applications for electrical. That's it. Nothing else. Okay? All right. Now, the electrical industry has shifted. Thermal imaging is no longer optional. Okay? The electrical industry has already changed. A lot of contractors don't realize that right now. And I can tell you right now, my brother, who is an electrical contractor, has been doing this for damn near 50 years, wasn't even aware of thermography and how it could impact his business and maybe help him on service calls or reduce a troubleshooting time or find something in being proactive. Okay. So in today's electrical systems, they're more heavily loaded than ever before. We see the advent of these data centers. We're adding all kinds of devices, all kinds of electronics. Yes, we're reducing the footprint by more efficient luminaires and LEDs and things like that, but we're loading the systems up more with other things that are pushing our grid, like the EVs and things like that. So we have to adapt to that loading situation. And so you've got more heavy loading, than before. You have more people adding on to their existing structures and adding additional loads. We have a lot of systems that are filled with actually non-linear type of equipment nowadays because of the different drivers and the LEDs and things that we're talking about. We're increasing this non-linear, and depending on the system's design or the system you're working with, that can create other potential issues with elevated heat that compounded over time that you need to be aware of, or the customer needs to be aware of. Operating temperatures are getting hotter. Data center loading is getting hotter. Okay. Residential applications, things are getting more loaded than ever before. And all the new stuff. My brother is wiring his house right now that's basically an electronic house, and he's got so much technology in there that when you start doing the load calculations, instead of thinking you're reducing it, you're increasing it. And so it increases the size of the service. But with that, you have so many other loads that are in there. The other thing, again, is more sensitive electronic equipment. The more sensitive they are, the more current they're going to draw. So and then lastly, I guess, aging. We're seeing, things that are aging in ways that we did not see this happen 20 years ago. Older systems, conductors and devices and things were rated for things now, the loads that are being put on systems that they were never initially designed for, right? So electrical failures almost never begin with an arc or a trip, folks. They begin with heat. The heat starts. When you have circuit breakers, they have overloads, they have thermomagnetic trips, they have all these things, but they start. How many of you ever been to a project or job and seen a breaker that looks perfectly fine, only to have it fail and look behind it and see the whole back end of it's melted out? Right? That could have been an even bigger problem. It might result in having to replace the bus bars inside of a panel, but you could have prevented that. So with that said, let's talk a little bit about understanding what's called I2R heating. Okay, it's the silent destroyer. So when we're looking at this, it is I2R equals current squared times the resistance. Why does this even matter? Well, it matters because even the smallest increase in resistance, a loose termination, oxidation, something that wasn't properly torqued or over-torqued, damage to the conductor, depending on where you're at in the country, again, heavy amounts of corrosion, all those type of things can lead, even loose terminations, just that in general, can lead to heat rise because it increases the resistance, which causes more heat, which in turn increases the resistance again. And then the cycles accelerates over and over and over again to the point where it finally gets to what we call a thermal runaway effect. And it's the root cause of countless electrical failures, not just in industrial and commercial data centers, big commercial facilities, production facilities, but also in residential, light commercial applications as well. The problem is, as electricians, by the time we move in many cases, there's already an issue. And we may be thinking that we replace the breaker solves the issue. However, it could have damaged the bus, and a thermal imaging camera can detect this and look at it a little deeper than we could with the naked eye. Because we'll be looking inside the infrared spectrum and understanding how to read a thermography report and not cry wolf in the process, but being able to give tangible information to the customer. Now, here's what scares me the most, okay? If you think about it, and again, having an electrical practice that I had for years and not thinking much about it, just being kind of reactive, fixing things as they break or as they burn up. I've been blessed that I haven't, again, as an expert, and when I worked for the city of Alexandria, I got called out on a lot of fire calls and looked at it, and I saw things that were definitely due to damage that would have been detected by a thermal imaging camera. Now, again, it's the chicken or the egg. When did you get there? But there's many times when we have an opportunity to get in there. And then for a very savvy electrical contractor, they can sell a maintenance program or a biannual or annual or monthly maintenance program on all of their service projects. You just have to be creative, but you're not selling snake oil. You're looking for possible issues. Now, again, here's what scares me. A circuit breaker doesn't need a heavy load to fail. All it needs is resistance. Now, we've seen breakers that look perfect in the front, but behind them, they're fully melted away back to the stabs. Okay? Lugs completely oxidized, conductors annealed and discolored due to heat, insulation cooked and brittle, or if it's thermoplastic, it's actually dripping plasticizer, which is regressing out of the insulating material, which gives it flexibility, which ultimately is going to reduce the thermal lifespan of that insulation because we didn't take loading into effect. But nobody knew these things until you start understanding the true thermal effects of overloading, overcurrent, mutual current, mutual heating, all these things. The panel looks normal. The breaker looks normal. There's no odor. There's no trip. There's no indication of danger. It hasn't tripped off yet. But the thermal camera would have revealed a hot spot behind the breaker, an abnormal thermal pattern, a temperature rise inconsistent with the visible load, and a signature of a failure in progress. But you, just looking at a bunch of color palettes, may not understand this. It's just like anything. You should not be using a tool that you're not educated in. And that's all we're doing. I don't want to be a reseller of cameras, folks. We're signed a partnership. We're working with Milesy, which is, if you don't know who they are, Google them. They are the leader in thermal imaging cameras around the world, not just in the US, but around the world. They make measuring devices as well. They make thermal optics for hunting. They make thermal optics for golf. But they are an amazing company with amazing technology that hold hundreds and hundreds of patents. You may have heard of just one big name here in the US. And they offer training. But that's internally to them. It's not genuine third party. So we don't want to be a manufacturer. This is why we approached Milesy and said, you know what? You can't do what we do, and we have no desire to do what you do. But we know education, we know training, and you know thermal imaging cameras. Let's partner up and offer a third-party, unbiased training program. And to be honest with you, you can get into our program and use any thermal imaging camera you want. Now, we may offer you some at good deals because of that partnership, but you don't have to buy our camera to get in our program. You go to one of the other big names, they want you to use their cameras. We just want you to learn. That's the key. I want you to learn. I want you to do it right. So if you get a thermal imaging camera, whatever level you get it at, you need to do yourself the justice, and we have kept it so affordable in order to get a certification program and give you the information and the fact that you're not just one and done. What it means is we're going to continually to add modules to this program so that you always can go back in there and learn more stuff. Okay? So that is why when you walk into a service call without a thermal camera is like walking blindfolded into a room. Okay? The system is giving off early warning signs, but you can't see them unless you're trained and equipped for that. And that's exactly why thermal imaging has become essential under NFPA 70B, especially with the new emphasis on thermal inspection in electrical preventative maintenance programs. So whether you're new to that or you understand it or you're in commercial, industrial, which you already have a preventative maintenance program, it has become essential now under NFPA 70B for you to understand it. So somebody in your program needs to understand it. The difference in our program is I am not going to weigh you down with the fluff of a building envelope and water migration and temperatures, whether you have insulating material. I could care crapless about that, folks. I'm an electrician who trains electricians. I only care about electricians. That's why we built our program the way we did. And we think it's the best out there. Hands down. I am biased at that, but that's what we built. Now, let's talk a little bit more here. Let's go into understanding NFPA 70B And there's a requirement in NFPA 70B to test things under loading or at the minimum of 40% load. Now, let me make this clear. NFPA 70B now makes it clear. It says to get meaningful thermal imaging data on electrical systems, you need a minimum of 40% of the equipment's rated load. That's it. But I want you to remember a few things. Even in residential, which you're outside of your scope of 70B, poor connections, poor terminations, remember that I squared R effect. In poor terminations over time, you could have a very little load running through a device and still have it generating abnormal heat. Why? Because of a poor connection with a high resistive point. And it's just waiting to fail. And it may have very little load on it. That's very much a fact. So don't get drawn down the rabbit hole of saying, well, there's no way I could ever use a thermal imaging camera because I can't guarantee a 40% loading in a residential application or even a commercial application. You know, I can do that for motors. I can do that for commercial equipment, transformer loading. I could do all that. But you have to think bigger. You have to think outside of the box. Okay. Now, why would NFPA 70B do that? Well, because that threshold, small temperature rises may not show up clearly enough to be meaningful in the real world scenario. Now, in a residential scenario, a temperature rise over the mutual ratings or the mutual temperature of the other breakers around, it's going to make something stand out and going to warrant further investigation. It's not the smoking gun, but it's going to warrant that investigation. And the loading can be compounded with the fact that it is a high resistive point where there's a problem. But you know what? There are things that we can do, even in a house. And you can be creative as a thermal electrician, a certified thermal electrician, right? So how can we do that? So it's very easy in commercial. It's very easy in industrial. It's very easy for motors. Just turn them on and load them up. Let them run for 10, 15 minutes, and then you can start doing measurements. Even if you're doing baseline so that you have a baseline for annual inspections, okay? Even if you're just doing a qualitative versus a quantitative evaluation, you can get baseline information. But how do we do this for, let's say, dealing with commercial or residential where we don't have consistent loading? Even again, low loads over a poor termination can yield effective values when you're looking at it with the thermal imaging camera. Let's assume not. So you ask yourself these questions. As an electrician, this is where you get confusing for people. They go, okay, how am I supposed to get 40% load in a house? What if the customer isn't using anything? Do I just wait around for the loads to increase? No, you create your loads, and it's not brain surgery. You're getting paid to do an evaluation by the hour. There's a lot you can do in this, okay? And I'm going to give you some tips, okay? You create the load. Number one, you can use hair dryers. You can use toasters. You can use space heaters. You can use mini ovens. You can use the clothes dryer. You can turn on vacuum cleaners. You can use microwave ovens. Okay, if it's a 20 amp bathroom circuit, you can put a hair dryer in it. You can do a space heater. You can create load boxes, where basically it's just boxes with various types of. I know one guy who took a box and he had 3 or 4 of hair dryers in it. Okay, and they blew out these vents. They put the end near vents, and they had vents in the side so air could move through it. But they had switches on the top that basically was a power strip underneath, and he could control how many hair dryers were on, and he used that as a load box. And he had a couple of them, he'd put them on different circuits and just let them run. And he would check the circuits. He would go around, he would do the big stuff first while he loaded those up. You can get hair dryers very cheap. Okay, they're not expensive. And he would load them up, and he'd have 4 or 5 of them running on the general branch circuits, things like that. He would turn all the lights on, okay? And then what he would do is he'd turn the oven on, and then he would turn a microwave on, and you turn loads on and let things run for about 10, 15 minutes, right? And then he would start doing his evaluations in the panel. He would do his evaluations at switches. Okay, he would adjust emissivity as needed, whether it's plastic or metal or whatever, and he was well trained. but he created his own loading, folks. Okay. And you might say that's just too much work. It's not. And if you're a professional, I can create what I call a load box and make it look very professional, have it designed pretty nice. We're going to be working on developing a load box that you can get from us that is very professional. And, we're going to use the basic understanding of hair dryers. We're going to create the box or the concept and maybe even give you drawings on how to create your own. But it's not brain surgery. Okay. How to do this. And basically you could do it with a hairdryer. You just need to put it in something so the hairdryer is just not laying on the floor. It actually holds it up and keeps it, just in place so that it's solid. And in your plug, you'll have various ones you plug into the different circuits. I recommend that, for example, over toasters or anything like that, or space heaters. Hair dryers, simple. Typically, they pull 12 to 15 amps, more than they're going to get that 40% loading on the circuit to do your testing. But again, you may not even need it because some breakers just may have a poor connection, and it's going to elevate. It's going to stand out amongst the others in the panel. Folks, there's a way to do this, and we train you on that, okay? But don't think that I can't do this. There's no way I could know. No, you can. All right. So let's just use an example. If I have a 20 amp bathroom circuit, I want to test it. I put on a hairdryer. They may even have a hairdryer. Turn it on. It's 12 to 15 amps. Instantly, you're at 125 to 140% of a usable load for diagnostic purposes. Now, if you're in a commercial environment, you can turn the HVAC system to call for cooling. You can energize the lighting circuits. You can start motors under controlled conditions. You can use portable heaters as load banks. You can get load banks as well that we use. You can enable equipment that is normally off. You can turn it on. So NFPA 70B gave us the number. You as a professional have to create the condition. And some people say, well, that's just too much work. Well, you know what? We're here to evaluate systems, and you're loading the system up for that evaluation. If you're the electrical contractor that comes up with a plan, a structure on how to promote this to your customers, how to head off possible issues in aged homes or other homes for future, then you can learn how that's going to be a marketing technique. And maybe you do find something wrong in a system, or maybe you don't, but you offer that service to your customer. Now, you may be able to go on a service call and you're there for 15 minutes. You get paid by the hour. You've got more time there to say to them, would you like us to do a thermal evaluation? We'll look at your terminations. We'll load it. We'll put load banks on it. We'll see to make sure everything's running good and not overheating. There's not a problem. All they can do is say yes or no. That's all they can do. But you really are looking for issues. You're not being a snake oil salesman. And if you also are just doing the evaluation of a panel anyway, even if you've got your thermal camera, you should be doing that anyway. Even if there's not evidence of loading, but you should do it to see if you have any high resistive terminations that could be doing the I2R issue, that hidden heat issue that's maybe behind a breaker or at a poor termination. Okay? I'm just saying, there's ways to do it. NFPA 70B gave you the foundation, but there is ways to achieve that. Now, let's talk about the full scope of what thermal imaging actually reveals. So most people think thermal imaging is just checking lugs, seeing hot breakers, finding loose connections. That is maybe 20%, if you will, of what a thermal imaging program can do. Let's look at the other aspects of it. And you may even be familiar with things like it can see motors. It can see the windings. It can see transformer windings. It can see all these type of things as well. But I want to tell you something about thermal imaging that you need to understand. Thermal imaging can't see through walls and be accurate. Thermal imaging is measuring the surface that you're putting the device onto, that you're actually pointing the camera at the appropriate distance, understanding reflection and understanding emissivity, and positioning yourself to get the best possible result. It's not going to do you any good at trying to look through a wall. Okay, that's only works on TV. Now, when it comes to motors and transformers, you can't get into the windings inside of the motor, So what you got to remember is that the temperature on the outside of the motor is going to be different than what's inside the motor. So if the temperature on the outside is very excessive, then you know that the temperature inside is way more than that, and that's a potential problem. So you learn the nuances of evaluating things like that. But a lot of people use thermal imaging, especially when they're initiating an installation of a new motor, let it run for a while and do some baseline testing. You're going to do thermal imaging of the actual frame and everything to record those values so that every month or every 6 months or whatever, you're comparing what you have to your baseline. So you're not getting into the windings, but you're getting the baseline from the housing. You're getting values, and you're using that as a comparative value as an ongoing maintenance procedure. And so if you see a sudden spike in the outside frame, which you know is going to be not as hot as the core, but you see this real spike in there that you're not used to seeing, then you know something else is going on, and it furthers some more evaluation. Again, you're not Superman, but that's when we use baseline values in an ongoing preventative maintenance program, and you should be doing that on every data center, every building that has a motor. You should be recording these data. You should be keeping it and use that as preventive maintenance, and that is what the importance of 7DB is all about. So going into residential diagnostics, because people don't think about this, but thermal imaging exposes overloaded multi-outlet circuits. Okay. The loads aren't balanced properly. Okay. They could have installed them improperly, and so the neutral's getting more current than it should. Loose backstabbed receptacles, believe it or not, you can detect that. You can see an elevated temperature spike. Yes. Overheated neutrals, high-resistant connections, breaker stab heatings, bootleg neutrals, multi-wire branch circuit issues, overloaded kitchen small appliance circuits, bundling in a panel that you may say, well, the code says that's not an issue because it's not more than 24 inches. But there could be an evident in there of such a higher that you're thinking, well, the code is one thing. But the reality is something's going to happen in those conductors that are in that bundle. And maybe as a prudent electrician, I need to space that out a little bit to allow some heat dissipation. It doesn't matter. The code says it's okay. But a practical thing is, this is my client, and I need to make sure that this heat is dissipated because this is abnormally high. And when you say, well, what's abnormally high? Well, you know what the rating is of the insulation, right? Typically, it's going to be 90 degrees C. 194 degrees Fahrenheit. Any values you get much higher than that, hello. It's just a matter of time before you have potential breakdown. We know the code is the code. It's a minimum standard. We follow it, but it's not perfect. Sometimes, due to your due diligence, you can find other problems waiting that the code might not have taken into consideration. And it does a good job. Bundling, it does a good job of more than 3 current conductors and adjustment and corrections, but there is occasions where people don't understand the code and they may not have applied it properly. And heat is heat. It's not, it's going to be very evident. When you have current and you have conductors and you have current running through it, you're going to build heat. It just is what it is. Now, what about service equipment and panels? Okay, thermal cameras can reveal bus heating, an improper bus, a bus that maybe has a connection point that's gone bad and creates a high resistive. It's not touching completely and it's arcing, creating a heat. You could have hot stabs behind the breaker that are gone bad, neutral bars heating disproportionately due to possibly somebody doing something wrong in the original installation. Hey, you could have parallel applications where they separate the conductors and are taking it through, say, a ferrous sidewall. And so now they didn't run them properly. They didn't follow the rules of paralleling properly. And now you have heating that's taking place. That can be a problem. Big problem. Paralleling. You could have one conductor in a parallel application that's pulling a lot more heat than the others, and you're thinking, what the hell's going on? But it's because it's not balanced. It's not the same length. It doesn't meet all the paralleling rules, but nobody caught it until one day you catch it and you see that conductor is overheating, and eventually that conductor will break down and take a system offline. Now you're thinking that's not going to happen in a residential. No, but it very well could happen in a data center or a large commercial building that the uptime is the imperative importance. And you can be that person that checks that. And every data center, I don't care. I can tell you right now, I did not make it to, folks know that I worked for Encore Wire for over 11 years. I ended up at Encore Wire because of a data center issue that Daniel Jones pulled me into. I worked for NEMA. I was able to find that the engineer that designed it wrong. It was a thermal loading issue. It was causing products to melt down. If they had used a thermal imaging camera and they had to understand the nuances of it, they could have found this answer quickly until it started breaking down. It was an engineering design flaw. I found it, and that started my relationships with Encore Wire. And finally, Daniel Jones said, you know what? I'm tired of you flying out here to solve our issues with us. We appreciate it. How about you come to work for us? And that's what started this whole thing. A multi-million-dollar project issue that I made go away because I pointed out that it was an engineering design. It wasn't a failure of our wire. Huge. Everybody should have a thermal imaging program in place and understand how to do it. That's important. Metering equipment overheating, SE cable insulation temperature breakdown, main lugs with developing resistance due to poor terminations, poor oxidation, improperly done. How many times have we heard that old story where we look and we see that everything looks good, but we find out that it was never torqued, so it was loose, and when it's under load, that's when you get that I-squared-R issue, and as the heat builds up due to current flow, slowly over time, that lug starts to heat up and everything around it starts to melt down until finally, when things burn up, they finally just burn up. I love when people say, hey, it's been that way for 20 years. Well, houses are that way for 20 years, 30 years, 40 years until all of a sudden they burn down. Okay. When it happens, it happens. No sense looking in the past when we now have the ability to look at something and be preventative. We can take action up front to review things. We never could do that before. And even when thermal imaging was in its infancy, people did not understand how to vastly utilize it, especially in our electrical trade. Originally, it was great for thermal imaging, building envelopes, energy, making systems energy efficient when it comes to buildings envelopes and get into the energy codes and all this kind of stuff. Yes, you're taught in all these programs the electrical, but that's just one piece. That's what we focus on. And by the way, our course is usually a third or less of what those programs are because we're not going to teach you those things because they're unnecessary for what you do for a living. That's what we want to focus on. What else? How about transformers? Small or large transformers. You can detect overloading in the transformer, the windings, internal winding issues, temperature variations at certain points in the windings. It could be a problem with the winding. It's not consistent across the winding itself, which it should be if it's evenly connected and evenly loaded. You have the terminal heating. You have cooling fan or airflow problems. You'll notice that the heat seems to be segregated in one area, so you're not getting good airflow through a transformer if it has an internal blower. There's so many things. Also, phase imbalances when it comes to the transformer. Not doing things properly are going to be evident because you know what? You're not going to hide the increased resistance, which is going to yield higher heat, and that's going to be projected onto the conductor and the termination. And you cannot see this with the naked eye. What about motors? What about mechanical components? Motors tell stories with heat, my friends. Whether it's a bearing failure, shaft misalignment, starter contact resistance, uneven phase loading on a motor, overcurrent or overload situations, improperly sized thermal overloads. All these type of things, if you understand what you're looking at, thermal imaging cameras and an ongoing monitoring basis, like taking a picture of it, putting it in your records, taking another picture a month later, seeing if it's consistent under normal loading conditions, helps you create baselines and you can be proactive. I'm telling you, I could not get into this industry today if I did not think that I needed to understand thermal imaging and add it to my portfolio. It's not just residential, commercial, industrial. It's everything. It's just another tool for your toolbox. If you use it once a month, if you use it 2 times a year, it may just save your butt and save your customer's butt. I'm just saying. Now, what about lighting systems? LED drivers and ballasts fail thermally long before they fail visually. It may look fine. How many of you have seen ballasts and looked at luminaires and think that looks great, that looks fine? But all the while, it's overheating. It's going to be imminent failure. And you can be proactive with it. What about rooftop units, folks? The contactors, the capacitors, disconnects, compressor windings, fan motors, control boards, looking for hot spots, looking for things that are abnormal. Thermal imaging cameras can see things that you cannot, but if you don't know how to interpret the value, then what happens is you cry wolf. You say, oh, you got to shut this down when that might be normal operating temperature based on the load and effect. You need to understand the difference. We don't want you crying wolf, but we definitely want you to be able to see what the problem may be. Okay? Fuses. I can tell by looking at something when I'm looking at it and I'm saying, well, I can tell under a load condition whether a fuse is blown or not, or the fuse is having potential problems. While it's still running, it's not fully blown through yet. There's things that you can determine with a thermal imaging camera that can just save you time and be very proactive and keep the uptime up. What about commercial electrical rooms? Routinely monthly imaging can save you. I'm telling you, it gives you load trend analysis, harmonic heating detection, understanding how the heating is going to be transmitted based on different load conditions, partial failures before they escalate. You can find little things that you can keep fixing in order to maintain the optimal performance of your system. Also, you can identify things for ongoing preventative maintenance like seasonal load changes. You know what to expect in the wintertime than what you is in the summertime. Those type of things. No other tool gives you this kind of insight if you understand how to use it. Okay, now, why electricians should use a thermal imaging camera on every single service call. Okay, now, here's the real business side of it, folks. Look, reason number 1, instant diagnostics. You can find issues in seconds that would take hours to locate with metering testing. That doesn't replace metering. You're going to have to, in many cases, we teach you to also use an amp probe in order to get a good full picture of what's going on. But it puts you where you need to be and it narrows it down for you. Instant diagnostics. Number 2, faster call resolution. A scan tells you exactly where to focus your time and your efforts. Rather than just doing a wild-ass guess, it helps you narrow down where the problem may be. It's not going to replace your skills. It's just a tool in your toolbox. Number 3, more billable work. If you find these issues the customer has, they didn't have any idea they had it. You can quantify it because you can actually show them this on the thermal camera. You learn how to explain it to your customer. We even give a module in our program, unlike anybody else. Nobody does this. We give you a module in our program on how to sell and convey the information to the customer. Because we're not here to sell snake oil. We're here to sell real results that are quantifiable by imagery. I can point out, and it's easy for people to see. We can look at it at different color palettes, different color spectrums, and explain, this is what's going on. We need to fix this problem. Because it could be a problem down the road. And if they don't do it, you know what? And it does fail, they have nobody to blame but themselves. Now, what's another reason? Higher professional perception. Customers instantly see you as the expert because you're using a tool that the other guy isn't using. So you hear me talk about this all the time in marketing. While people get the CMECP program, Certified Master Electrical Co-Professional Program certification, is it required? Absolutely not. Should every master electrician think about it? Yes, if you understand marketing, if you understand how to put yourself above your competition and how to stand out in the crowd, how to use it when you're doing marketing leverage, how to letter your vehicle, how to promote it on your business cards, how to talk about I've gone over and above what the normal master electrician has to do to get this certification. If you know how to do that, people say all the time, well, what is it going to get me? Is that all you want? Is what it's going to give you? Okay. Well, what it's going to give you is an edge over your competition. Well, the same thing here for thermal imaging. You understand it. And again, the vast majority of electrical contractors out there don't understand the proper way to use thermal imaging, how to incorporate it into their business. And it's a sales piece, a marketing piece, diagnostic piece, advanced technology piece that your customer may have never seen, and it gives you talking points, right? All win-wins, folks. Win-win. What's another reason? How about liability protection? Here's your thermal scan before and after. That documentation keeps you safe. So preventative maintenance, anytime you're installing a new piece of equipment, get it loaded, install it, run it for 15 or 20 minutes, do an image of it, take a regular picture and a thermal imaging picture, keep that for the records, use that as your baseline. Also in a dwelling, you go do a service call. How many times have you as an electrician gone and done something that somebody calls you and says, hey, something stopped working after you left, or this melted down, or something burned up after you left? Well, dude, I'm going to do a thermal scan of every panel. I'm going to have a thermal scan, and I'm going to put that, and I'm going to include that with a report, and I'm going to say, hey, I did a complimentary thermal scan. Everything's good, so that if something happens after I leave in that panel, they can't come and say to me, oh, it's because you didn't see this breaker was bad, or this one had a poor connection. I'm going to do the best I can to try to have that due diligence. So if you end up in court, you can say, look, Your Honor, I'm not a magician. I'm an electrician. But you know what I did do? I went that extra effort and used a thermal imaging camera to try to capture some baselines for the customer as a courtesy. Again, it's a snapshot in time. I did the best I could with it. And you know what? You call me as an expert, I'm going to be able to support you in that and say, you know what, Your Honor, as an expert here, they did about all they could do in this situation. So again, it's a little extra liability protection because every panel you touch, everything you stick your hands on, if it fails right after that, whether it's a day after or 2 months after, guess what? The customer always says, well, the last one that did anything was the last electrician that was here. He must have screwed something up. It's very affordable. It protects you. And as long as you get into that mentality, and maybe you don't care, that's fine too. But today, people are getting very litigious the way they are. And trust me, a customer that acts like your friend, something burns up or something burns down, and they tell investigators that you recently had some electrical work done or somebody came in, guess what? You are now suspect. Doesn't mean you did it, but you're now suspect. Okay? So anything that I can put in my pocket to help me as a licensed professional with a certification on thermal imaging in my back pocket, it's going to say, look, it was fine when I was here. There's nothing I did that caused anything. All this stuff was fine. All of that type of stuff helps protect you just a little bit more. Reason number 6, maintenance contract opportunities. Commercial customers love thermal trend data. Whether you're adding this to your normal profile, whether you know whether you want to get into some data centers and offer them a third party, go to them and say, look, I know you've got property maintenance guys, but we can offer you a third party thermal imaging and do it on a monthly basis to make sure you increase the uptime. We're going to look for any abnormalities, and we're going to keep this baseline data, and we're going to have it, and we're going to compare it every month so we can see any trend, because heat rises. Okay? So there's a lot of opportunities for maintenance, commercial applications. Big buildings like the Walmarts and whatever have rooftop units. Anything that you can develop a maintenance program that's a baseline that's going to be over and above what their normal maintenance folks do. They don't know how to do this stuff, folks. You can get creative and create programs and add these programs. Again, people say, well, ain't nobody going to come. Look, they are not going to come unless you build it. They're not. You have to build. You have to work at something. We're not giving it to you on a silver platter. You got to work a little bit. Reason number 7, safety, reliability, and code compliance. NFPA 70B is pushing the entire industry towards preventative thermal diagnostics, which you can put in your pocket when you explain that to your customer, that this is a changing world, that we now have specific guidelines that we should follow, and I can offer you that and keep it safe, reliable, and compliant. Now, let's talk about how the Certified Thermal Electrician program can elevate your skills. This is our program specifically. So most thermography courses cover camera focusing, building envelope, HVAC focused, or generic infrared tech type training. But you know what? Electricians aren't scanning roofs. They're not scanning duct systems. You're scanning electrical systems under load condition. You need training in NFPA 70. We do that at Electrical Code Academy. We teach you the NEC. You need training in what's necessary on NFPA 70B. You need to understand 110.14c temperature limitations. We cover that. We explain that. You need to understand insulation temperature ratings, emissivity for electrical metals. You need to understand proper camera distance and angle and reflection. You need to understand load creation methods. You need to understand temperature interpretation, diagnostic logics, proper documentation and reporting. You need to learn when to not cry wolf and when you need to advise your customer to monitor a situation and offer a follow-up service. Follow-up services are huge. Trust me, it's much cheaper to have you follow up than it is for them to have to replace it when it burns down. Trust me. And you're saying, well, what has changed, Paul? Over the years, we never did this type of stuff. The loading has changed, folks. System has changed. Demand has changed. It doesn't take you long to look around and see that the people are consuming current like they're going mad with the advent of EVs. And systems weren't designed for these, but people are adding them in the home all the time. And they're not always doing load calculations on their dwelling. They're adding additional loads that if you have poor terminals at the main or poor connections at the meter can create potential problems that may not have been there before they added on these additional loads, which again translates into heat. There's so many factors that change it today. That's why we created the CTE program, the world's first and only thermography program built exclusively around electricians. It's not generic. It's not watered down. It's an electrical thermal imaging done right the right way. Proper code, proper science, proper procedures, proper safety, real world examples. That's what the CTE program is all about. So, look, I'm going to be straight with you. It's not a selling. We sell courses. We can give you the best deal for the best professional grade thermal imaging cameras that you don't have to spend thousands of dollars on. We can help you with that if you don't already have one. But if you're not using a thermal imaging yet, you're behind the times. Not because others are doing it, but because electrical systems require it. Thermal imaging is a diagnostic tool, a preventative maintenance tool, a liability shield, a customer education tool, a revenue generating tool, a safety tool. And to be honest with you, it's a professional differentiator between you and your competition. And if you want to master this and understand how to interpret it, how to look at and see trends that are coming in the system, you want to be elite and stand out above your competition, or at least push your competition to be on par with you, then you need to look at our CTE program, Certified Thermal Electrician. It's only available from Electrical Code Academy. You can go to thermalimaging.com. Our courses are hosted by ECA, which is our corporate office. We've been around for a long time, folks. I've been teaching this stuff for nearly 40 years. I serve on Code Making Panel 5. I serve on Code Making Panel 17. You're saying, okay, 5 is grounding and bonding. I understand those type of things. But where do you get your expertise when it comes to conductors and ampacity and temperature rise? Folks, I've been the director of technical services for the world's largest wiring cable manufacturer for over a decade. working very closely for R&D. I have 9 patents to my name in the wire and cable industry. I understand terminations. I understand heating. I understand the thermal impacts of doing those things improperly. This is all that led me to create this program. And this is why you don't get this anywhere else, only in our program. All right? Again, I don't want it to sound like a sales pitch because I'm passionate about it, but you need it. If you want more information on adding our services or adding our certification to your options as a professional electrician, do me a favor. Go to thermalelectrician.com. Thermalelectrician.com. Go there. Send in for some information. Call me if you want. My number is 540-607-0116. You can send a message through our system. Just do me a favor. Think about adding it to your toolbox because you're going to see amazing things and you're going to prevent a lot of things that can be prevented. All right? Okay, folks, that's all I got for you. Hopefully you got something out of that. Until next time, stay safe, God bless, and we'll catch you on an upcoming episode of Mastering the NEC. Till next time, peace.
Thanks for tuning into another electrifying episode of the Master The NEC Podcast. We hope you're feeling more powered up and ready to tackle the electrical world with the knowledge and confidence you need to succeed. Remember, in the electrical trade, knowledge is power, and we're here to make sure you stay plugged into the latest insights, tips, and code updates. If you enjoyed today's episode, don't forget to subscribe, leave us a review, and share the podcast with your fellow electricians and industry pros. Until next time, keep your tools sharp, your circuits clear, and your mind focused, because here at the Master The NEC Podcast, we're all about sparking your success. Stay safe, stay smart, and keep mastering the trade. From all of us here at Electrical Code Academy, thank you for all your support, and we will see you on the next amazing Master The NEC Podcast episode.